Hey everyone, so we're going to go ahead and get started with thermochemistry. This is one of my favorite units because it has to do with energy changes and usually involves some sort of explosive reactions, which you all seem to like. So we're going to go ahead and get started with the flow of energy as part of chapter 17, section 1, part 1 to be specific. But before we get into actual flow of energy, we need to define thermochemistry. Thermochemistry specifically is the study of energy changes that occur in a chemical reaction. So whenever you think of some sort of explosive reaction or a reaction involving a temperature change, it involves the study of thermochemistry and how energy changes to make that reaction occur. So at the end of this video, we should be able to explain how energy changes occur and then describe situations of energy flow, both at the big picture level and at the chemical compound microscopic level. How is energy involved in a chemical reaction? If we have a molecule like water, oxygen bonded with two hydrogens in a liquid or gas or solid state, that oxygen-hydrogen bond has energy in it, has chemical potential energy stored in a bond. And that energy stored in the bond is used to do reactions, either breaking it to use that energy or adding on with energy required to add on something. So the energy of a bond, chemical potential energy, is used in a lot of chemical reactions to make things occur. At the big picture level, though, when we think of energy flow, let's use an example that we're all used to every single day. When we need energy, we need to eat food. And if we are going to eat food, we're going to take in the calories. Calories is a form of energy, and we're going to talk about that. But we take in calories to get our energy, and specifically we get calories from food. We have a couple of connotations or indications on how to talk about when energy is flowing from one thing to another. The system, which is you or me eating food, would be the thing taking in energy or releasing energy. And the surroundings is where we get the energy from. Either, in this case, it's from food or something else in another case. But we have system and surroundings. So the system, which is either us or whatever is taking in or releasing energy, can either release energy in an exothermic reaction to the surroundings, or they can take in energy from the surroundings in an endothermic reaction. There's those words again. Either taking in heat in an endothermic reaction or giving off heat in an exothermic reaction. So let's take another example. If we have soda and it was warm, we would want to add some ice so that it cools down. And normally we would think that ice provides some sort of cooling factor to make the soda cold. But that's actually not what's going on. What's actually happening is that the ice is taking energy from the soda that's warm to make it cold, and that's why our ice eventually melts. And so if you don't drink your soda enough, it might get diluted because the added water from the melted ice, and it tastes weird. But ice is not providing coldness to the soda, it's actually taking away some of the warmth. Cold is actually not a correct term. What's actually going on is absence of heat or absence of temperature. So the warm soda is becoming cold by having energy taken away from it by the ice. Energy in the universe, though, is somewhat constant. The sun heats the earth and gives energy to the earth for it to do its processes, and earth then releases energy either into space and it leaves the earth's atmosphere and goes into space, or it gets bounced back by the ozone layer back to the earth, which causes a global warming, and we'll get into that later. But overall, though, there's this law of conservation of energy. Energy is neither created or destroyed during any chemical process. It remained constant. So another thing with law of conservation of mass is that mass is neither created or destroyed. Same idea here. Energy is neither created or destroyed. It remains constant. And we'll get into how that might affect the universe a little bit later. But for today, We went over our two objectives. We explained how energy changes occur with flowing from either exothermic or endothermic or system and surroundings. And we described two examples of how energy flows, both at the macroscopic level and the microscopic level with chemical potential energy. So for tomorrow, go ahead and think of an example of energy transfer and bring it to class. Make sure you identify system and surroundings in your example. The most creative one is going to win some extra credit points. So I'll see you all tomorrow.